Applied systems thinking on event-driven architecture. Event-driven architecture doesn't remove dependencies. It turns them into dependencies on information. Instead of services directly depending on one another, they begin to depend on the events that flow through the system. And when systems depend on shared information, change propagates through events. That is the behavior most architectures underestimate. This is where many architectural discussions about event-driven architecture stop. They talk about loose coupling. They talk about scalability. They talk about asynchronous systems. But systems thinking asks a different question. What behavior does this architecture create? Because architecture patterns don't just organize software. They shape how systems evolve over time. Most organizations adopt event-driven architecture to reduce dependencies between services. Direct service-to-service calls create tight coupling. If one service changes, other services may need to change as well. Events appear to solve this problem. A service emits an event describing something that happened. Other services react to that event. No direct call, no synchronous dependency. And in theory, this allows services to evolve more independently. Teams can deploy systems without coordinating every change. That is the promise. The mechanism behind the pattern is simple. Services publish events. Those events are distributed through an event broker. Other services subscribe and react. Instead of request-response communication, the system becomes asynchronous. Events represent facts about the system. An order was placed, a payment was completed, a shipment was created. Consumers observe these events and update their own state. Communication shifts from direct interaction to information distribution. This pattern exists because modern systems operate under strong pressures. Systems must scale. Teams must deploy frequently. Failures must not cascade across the architecture. Event-driven communication helps address these forces. Services can react independently. Systems can process work asynchronously. Teams can evolve services with fewer direct dependencies. But responding to those forces introduces something else: new system dynamics. Because once information begins to flow through events, the system begins to behave differently. The first dynamic is event propagation. A service emits an event. That event may be consumed by multiple services. Each of those services may react by emitting new events. Those events may trigger additional reactions. What started as a single event can spread through the architecture. The system begins to behave less like a sequence of service calls and more like a chain reaction of state changes. The second dynamic is temporal decoupling. In synchronous systems, cause and effect are immediate. A request is made. A response is returned. But in event-driven systems, reactions happen when consumers process the event. That might be milliseconds later. It might be seconds later. It might be minutes later. Queues buffer events. Consumers process them at different speeds. Failures delay processing. The system no longer behaves like a single coordinated execution. Instead, it behaves like many independent timelines reacting to the same information. The third dynamic is the one architects often underestimate: change propagation. In synchronous systems, dependencies are visible. If service A calls service B, the relationship is explicit. In event-driven systems, dependencies become indirect. A service emits an event. Many consumers may depend on that event. Often, the producer does not even know who those consumers are. Over time, events become shared system contracts. And once multiple services depend on the same event structure, changing that structure becomes difficult. A small schema change can affect many services across the system. The architecture becomes coupled not through service calls, but through shared information. Taken together, these dynamics reshape how the system evolves. Events propagate through services. Reactions occur across time. And change spreads through shared contracts. At that point, the architecture is no longer defined by who calls whom. It is defined by how information flows. And when information flows define the system, Understanding the system requires understanding those flows. If we look at the structure created by event-driven architecture, it no longer resembles a chain of service calls. Instead, it forms a network. Producers emit events. Brokers distribute them. Consumers react and may emit new events. Those events continue flowing through the architecture. The system becomes a graph of information flows rather than a sequence of interactions. And every new consumer increases the number of relationships inside that graph. From this structure, predictable behaviors appear. Understanding the impact of change becomes more difficult. Event schemas become long-lived system contracts. Debugging requires tracing how information moved through the system, and system understanding shifts from individual services to the flow of information between them. Event-driven architecture does not eliminate coupling. It transforms it. From direct service dependencies to dependencies on shared information. Event-driven architecture is not primarily a communication pattern. It is an information distribution system. And when information flows through a system like that, change flows with it. Understanding that dynamic is what allows architects to design event-driven systems that remain adaptable instead of fragile. Because architecture is not only about how systems run, it is about how systems evolve. And keeping that in mind is systems thinking for architects.